Okay, so here we are with semester 3 for chapter 2, which is a hydrocarbon, where we are going to continue from the errata part that I did not manage to present on the last YouTube video. So today I'm going to do a replacement here. So let's continue with how to answer the essay questions for chapter 2, which is about hydrocarbon. So I'm going to share with you on what are the things that you are required to know while attempting to understand the essay questions and the requirements of the questions in here, and what are the strategies that you might apply in answering this essay question. So with that session, let's begin our discussion. So let's start from number 1. So number 1, what is meant by stereoisomerism? So in here, you are required to define what is the stereoisomerism. So stereoisomerisms are molecules having the same molecular structure. That is the first key point that you might want to write. Okay, molecule having the same molecular structure, but different arrangement in space. Now, if I were a student, I would usually try my best to define as fully as I can on how to define the molecular structure. I will even mention that which includes geometrical isomers and also optical isomer. Okay, so I might want to continue. Okay. And so on. Okay, so do not stop until here. As I always tells you all when answering essay, do not predict where are the marks located. As a student, you should try your best to write as fully as you can. Okay, so that is for how you answer number 1A. Now number 1B, an amount of 0.1 mole of the hydrocarbon. So you try your best to highlight wherever possible. Okay, 0.01 mole of hydrocarbon. Okay, so it must be a CXHY. Which is burned in excess oxygen. So the product of the combustion are passed through anhydrous calcium chloride and through potassium hydroxide solution. So the mass of the anhydrous calcium hydroxide and also potassium hydroxide solution increased by 0.72 and 1.76 respectively. So you must understand what are the roles of the anhydrous calcium chloride and also potassium hydroxide, where the role of the calcium hydroxide is to used to absorb water. While the role of the this potassium hydroxide is to use to absorb carbon dioxide according to the equation. KOH plus CO2 give K2CO3 plus H2O. So that is how the reactions goes through. So whenever the question says that it increased by 0.72 and 1.76, it is referring to the mass of the water and carbon dioxide respectively. So that is something that you have to know about it. And because it is essay question, so you also might want to include this inside your essay answers inside there later. Okay, and for the potassium hydroxide with the carbon dioxide equation, please also include inside your answers in there. Okay, so in here, first of all, definitely you have to write the Mach equation. What does it mean by the Mach chemical equation? So you should be able to write the combustion of the hydrocarbon, where CHY plus X plus Y over 4 give XCO2 plus Y over 2 H2O. So from here, stoichiometrically, you can see that 1 CXHY reacts to form X carbon dioxide plus Y over 2 H2O. So in here, we are going to use the mole ratio of the hydrocarbon to compare to the carbon dioxide and water, so that you'll be able to determine how much number of carbon and how much number of hydrogen is inside the hydrocarbons in that. Okay, so first of all, calculate the mole of the carbon dioxide. So the mole of carbon dioxide is 1.76 divided by 44, which is 0.04 mole, while the mole of the water is 0.72 divided by 18, you also get 0.04 mole. So stoichiometrically, then you have to compare. So if you have 0.01 mole of the hydrocarbon is to 0.04 mole of the carbon dioxide and 0.04 mole of the water, what is the expected X and Y respectively. Yeah. Okay, sorry for accident. So you need to understand what are the possibles, carbon and hydrogen as respectively. So in here, you might want to write out find out what is the number of X and Y. So the number of X in here, since the ratio of the hydrocarbons to the carbon dioxide is 0.01 to 0.04, therefore it's 1 to 4, therefore your X is equals to 4. That means your hydrocarbon inside contain 4 carbon. Whereas for water, since 0.01 is to y over 2 times 0.4, so it's y over 2 is equals to 4, therefore y is equals to 8. Okay, so that is how you can compare in terms of this number of mole to identify what are the possible hydrocarbons inside there. So as a result, in here you can find out your empirical formula as CH2 and your molecular formula as a C4H8 in here. Okay, so just in case you might want to also write the empirical formula for the hydrocarbons involved. Okay, so as I always tell you, do not bother where are the marks located. So you must try your best to write out as fully as you can as a student. Okay, so that is how you answer for question number 1B1. And then 1B2, draw the structural formula of all isomers by this hydrocarbon. So if you have C4H8, so whenever you have C4H8, please always bear this in mind. Whenever you have a C4H8, okay, or you know by yourself that the empirical formula is CH2, okay? Therefore, you have to consider two possible functional isomer. The two possible functional isomer with the formula of CnH2n. CnH2n are either alkene and also cycloalkane. So whenever you are proposing the isomers for hydrocarbon, you must propose all possibles, including alkene and also cycloalkane. So if C4, what are the possibles isomer for C4H8? So these are all the isomers in here. So you shall have boot 1 in, okay? You shall have a boot 2 in, okay? You shall have a cyclobutane. You shall have 2-methyl propene. And you shall also have a methyl cyclopropane. So now STPM style of giving the marks is usually like this. They will definitely ask you to propose all possible isomers. So for each isomers that you do not propose, they will minus off 1 marks. So that in another word, if you propose all 5, you have 4 marks. If you propose only 4, you only have 3 marks. If you propose 3, you only have 2 marks. If you propose 3, you have 1 marks. Okay, so that is how usually STPM styles go. Okay, so that is all the possible isomers for the hydrocarbon. Okay. Okay, then number 3, if one of the isomers shows stereoisomerism, draw and name the stereoisomer. So in here you can see that the only possible structure that shows this stereoisomerism is this one, 2 in. Okay, you can see very clearly. And what is the possible type of the isomer in here? It is actually geometrical isomerism. So as a student, you just write, okay, it's geometrical isomer. Okay, since it's 2 marks here, the question already said draw and name, so 1 mark accordingly. So you should have a cis boot 2 in and also trans boot 2 in as your answer in here. Okay, okay. So with that, that is for how you answer for essay question number 1. Okay, so that is all for number 1. Immediately we move to question number 2. Question number 2 sounds like this. Chlorine gas react with 2-methyl propane to form a haloalkane compound as it's described in the equations below. So you have a 2-methyl propane react with 2 chlorine molecule to form a 1,2-dichloropropane. 1,2-dichloropropane. Okay, so describe the mechanism for the reaction curve. So a few things that you might want to take notes before answering this essay question is, you want to take notes that this is alkane react with UV. Okay, alkane react with UV. Okay, now this is an alkane react under with UV. So you must know by yourself that what is the type of the mechanism, type of the chemical reaction. Okay, so the type of the reaction is definitely a free radical substitution reaction. Free radical substitution reaction. So now, how are we going to propose the mechanism for free radical substitution reaction? First of all, you need to try to understand which part inside here is actually substituting. So you can see from the changes here, it is the first carbon and the second carbon which undergoes substitutions of the chlorines in here. So one of the knowledge that you all must know whenever you are trying to substitute chlorine is where should the chlorine be substituted? That is number one. And then number two, the preference of which carbon is more preferred to be substituted first. Okay, so if you look carefully, this is a primary alkane, while this one is a tertiary alkane. Okay. So it is to say that a tertiary alkane is preferred to be substituted compared to a primary alkane due to the stability of the radicals that is about to form later. Later, I'm going to explain how does the mechanism goes in here. Okay. Okay. So for a free radical substitution reaction, similarly, they all took 3 simple steps, where the first step is initiation. So you shall have initiation where the chlorine molecule, okay, undergoes homolytic fission. So this is a type of homolytic fission. Now, whenever you are trying to describe a homolytic fission, because only one electron, it is involving electron transfer for one single electron. So all arrow that represent for one electron in here, you use a half head arrow like this. Okay. So if it is 2 electron, later we will see in the alkene later, it is a full head arrow in here. So for radicals, it is a single electron transfer. So all of them must use a single head arrow. So including this one. So when it undergoes a homolytic fission where each of the electron is broken, the covalent bond is broken, and each chlorine possesses one single electron, which we call it as a radicals in here. Then the second step will be the attack of the chlorine radical. So now, as I mentioned just now, a radical will prefer to attack the tertiary alkane first. So you must try your best to propose the mechanism where you have the tertiary alkane is first attacked by the radicals. So in here, you should try your best to understand how does this bond fission take place when here the CH bond in here is first broken. So the radicals that is produced by the hydrogen will then combine or form a covalent bond with the chlorine molecule, leaving the carbons to become the radical. So therefore, you have a tertiary radicals in here. And the tertiary radicals in here is to say more stable. So, and then you form a side product as a HCl, which you must write in here since H react with the Cls in here. And the second step of the propagation is where the tertiary carbon radical, which is unstable, will then further react with another chlorine molecule via a homolytic fission. So the carbon radicals will attack the chlorine molecules. So the chlorine molecules again undergoes a homolytic fission and form the one of the product is 2-chloro-2-methyl-propane with a chlorine radical. Then this reaction is further propagate where finally now this hydrogen has been substituted, isn't it? So you can see the next chlorine, because our desired product is CCl, CH2Cl. So you must also propose on how does the chlorine radical attack the primary haloalkane in here. Okay, so the chlorine radicals will attack the CH3, which is the primary haloalkane. So again, it undergo a homolytic fission in here. So you form a CH2 radicals and together HCl as a side product. And then the CH2 radicals will then react with another chlorine molecule to form our desired product. This is CH2Cl. plus Cl radical. So in here, because our motive is just to propose on how does this product is formed, so you stop until here. Of course, in free radical propagations, there are much more steps that can take place inside these free radical substitution reactions. Okay, but since the questions only want to stop this, how does you form this compound? So usually we only stop at what we want from the equations in here. Okay, and finally, for a free radical substitution reaction, you must have the third step, which is a termination step. And the termination steps takes two of the radicals to undergoes bond fusion. Okay, where you are going to form the covalent bond in between CH2Cl radicals, CH2 radical with the Cl radicals to form our final product here. Okay, so these are usually how the steps by step of the free radical substitution reaction. So if you count properly, so there are 7 things that you describe here: 1, 2, 3, 4, 5, 6, 7. So that is how you get the 7 marks for these questions in here. So with that, that is how you answer for the 2A's in here. Okay, then we continue on with 2B. Explain how the formation of the side product 2233-tetramethylbutane is formed. So first of all, you must be able to draw the structure of 2233-tetramethylbutane. So if you don't even know how to draw, then you might face problem on answering this question. So let's first draw out the structure. Then together we try our best to understand how do you actually form this side product in here. So this is how 2233-tetramethylbutane looks like. So it seems that if you look back at our propagation steps just now, one of our radical form is this one, tertiary radical of 2-methylpropane radical. So this 2-methylpropane radical, okay, if you look carefully on back to the structure in there, okay. So it is actually a combination in between two radicals of these two similar radicals of 2233 2-methylpropane radical that will undergo collision to each other. So that is why you have this 2233-tetramethylbutane. Okay, so therefore you have to mention, because the questions wants you to explain, so you have to explain in words. So when two third-butyl radicals terminated each other, so you say termination occur in between two third-butyl radicals is formed. Okay, so as third-butyl radical is more stable and hence form the equation. So in here, or you can actually represent this one by using this diagram. Okay, this diagram is clearly showing how the two third-butyl radical is ready to collide with each other and form the 2233 tetramethylbutane in here. So that is how you form this side product of 2233-tetramethylbutane, which is from the termination steps of the third-butyl radicals. Sir, is mentioning the third-butyl radical important? No, not important. That's why I said you can use draw to represent these steps, okay? Because you are trying to explain how does the side product is formed in here, okay? So if you don't know how to name this radical, third-butyl radical, then just leave it. As long as you have diagram, shouldn't be much of a problem in here. Okay, then we go to B. 2233-tetramethylbutane together with another hydrocarbon as a side product can also be obtained through cracking process of the dodecane C12H26. Describe the type of the cracking process took place using suitable reagent or condition and write an equation for the reactions involved. Okay, now looking back at this 2233-tetramethylbutane, which is this structure, okay, you have to understand what is the possible type of the cracking process that you produce such a highly branched molecule. So the type of the cracking process take place in here, what we so call as a catalytic cracking. Okay, it's the catalytic cracking that is able to form this one. So you have to, because the question wants you to describe the type of the cracking process. So you have to describe why do you choose this cracking process as the answer in here. So why do you choose catalytic cracking? Because you have to explain that through catalytic cracking, you produce a higher octane number of hydrocarbon, or you say hydrocarbon that is highly branched. Okay. So the question also asks you to use suitable reagent and condition. Of course, you have to mention catalyze by using zeolite or aluminum oxide according to the equation. And the question also requires you to identify with another hydrocarbon. Do you see that? So the other hydrocarbon, as long as it is a C4H8, okay, Because if you calculate properly, altogether this molecule is already C8H18. So what is the expected side product in here? So you minus mathematically. So C12H26 minus C8H18. So therefore you have C4H8. So the side product in here, it doesn't matter what are the molecule as long as they have the formula C4H8. In another word, you can also answer as wood to in, no problem. Okay? Or you can also answer as 2-methyl propene. Okay? So any side products in here are correct as long as it is balanced with the formula C4H8. Okay? So that is how you are going to answer for essay question number 2. Then we are going to continue with essay question number 3. Cycloalkane and alkene has the same molecular structure. The structural formula of a cycloalkane is shown below. So this is a 1,2-dimethyl cyclohexane. 1,2-dimethyl cyclohexane. Number 1, state the type of isomerism shown by the cyclohexane above. So the question already gives you the molecular structure. When they already specifically give you molecular structure, it is ridiculous or it is nonsense if you are going to say that it is structural isomer. No, it is definitely not structural isomer. So what are the type of isomerism is usually referring to the stereoisomerisms present in here. So what are the possible stereoisomerisms present in here? Is definitely geometrical isomerism and also optical isomerism. Now, cycloalkane can easily exhibit both of these type of the stereoisomerism due to its unique structures that can easily be surrounded by 4 different atoms or group of atoms, or also carbon with 2 different atoms or group of atoms. Okay, so such molecule like this 1,2-dimethyl cyclohexane can easily exhibit both isomerism. So the 2 marks in here definitely goes to geometrical isomerism and also optical isomerism. Okay, then number 2, write the structural formula of an alkene with the formula C8H18 that exhibit the isomerism in 1 and draw all possible isomers. So in here, the strategy is how are you going to propose the alkene that will possess both geometrical and also optical isomerism. So the key is very simple. You have to understand what are the characteristic of a geometrical isomerism and optical. So let's start from optical isomerism first. So an optical isomerism, you must have a carbon surrounded by 4 different atoms or group of atoms. So the 4 different atoms or group of atoms is very simple. You first definitely start from a H, then you start from CH3, CH2. Okay, then another one is CH3. So any carbon that comes with 3 or more carbon can easily make this carbon a chiral carbon atom, isn't it? So in here, you can see that we already have 4 carbon, 1, 2, 3, 4. So we need 4 more, isn't it? Okay, so you sketch 4 more carbons in here. Then this behind 4 carbon, and now you already shows that this compound contain optical isomerism already, isn't it? Now, what about the other type of the geometrical isomerism? So geometrical isomerism must contain at least a C double bond C, and has number 2 surrounded by 2 different atoms or group of atoms. So this is also quite simple, where just draw this one as H. While this one also as H, then this one is CH3, then this one is CH2, and then you can already say that this molecule possess both geometrical and also optical. So can I move this C double bond C to here? Also can, no problem. So there are 2 possible answers that you can propose for the molecules that you have. So in another word, what am I trying to say just now is if you plot your double bond at here, okay, so they become C, CH2, CH3. Also can, no problem. So no matter where you put, as long as they will have a geometrical isomerism, then they are both correct. Okay. Okay. So that is how you are going to propose the type of the molecules that for C8H18 they will possess both optical and geometrical isomerism. So this is the answer that I wanted to show you just now. Okay. So this is the isomerism. Okay, so then you have a pair of geometrical isomer and optical isomerism. So you draw the cis trans pair. So it shouldn't be much of problems in here. Okay. Okay, so if possible, when the question also asks you to draw all these possible isomer, and then in here you try your best to mark the chiral atom. Here, just mark the chiral atom. You don't care whether the where are the marks located. As long as you draw the mark the chiral atom, then it should be fine already. Okay, okay. So with that, that is how you shows the both molecule with the geometrical and also optical isomerism. Okay. Last but not least, suggest a chemical test that to distinguish cycloalkane from the alkene in two. So state the observation and write the equation. 3 marks. Now always remember in a chemical test, there are 3. It may sometimes be 3, sometimes may be 4 marks in here. Regardless, 3 or 4 marks. 3 most important key that you must always write whenever you are trying to propose a chemical test are: number one, you must always have reagent and condition. Number 2, observation, which is a positive and negative test. You have to show both positive and negative tests. And finally, equation. This is a definite truth, unchanged truth, no matter how they are going to ask. As long as they are asking for chemical tests, this will always be the main key to propose a chemical test here. Okay, so you have to propose what are the suitable reagent and condition for the reactions, and therefore write the equation. So in here, between alkane and alkene, we have a lot of reagent that can do that. So of course, the 2 most major concerns are the 2 most convenient reagent and condition that you can use are either you use bromine or you use potassium manganate. Then, even if you use bromine and potassium manganate, be careful with the condition that you apply, because different reagent condition will give different product. Bromine in CCl4 and aqueous bromine give different product. Acidified potassium manganate or alkaline potassium manganate also will give different products. So you must be very clear and specific in here. What are the reagent conditions? What are the expected observation? And what are the equations that you are going to write in here? Okay. So if you use bromine, you say that brown color decolorized. If you use potassium manganate, purple color decolorized. While you also have to write the negative test. The negative test, no observable changes by cycloalkane in here. Okay, so alkene you have changes, cycloalkane show no observable changes. We penalize students if you write these terms for observation. No changes. No changes is wrong. Sometimes they may be changed, but it's just we cannot see with our naked eyes. So if you say no change, then cannot be accepted. Cannot see is also another. This one, cannot see means that you are blind. Okay, you cannot see. That's why you cannot see. Okay, so also cannot use this term cannot see. Okay, so either you use no observable changes or you see no visible changes also can. Okay, no observable, no visible, no significant changes also can. Okay, but the most common terms that we use are either no observable or no visible changes. Okay. Okay, and last but not least is the equation. So if you use bromine in CCl4, which is the most commented, most recommended, so you form Br. If you form use bromine aqueous, so you form a halohydrine. Okay, so you form Br and OH. This is the major product, and of course you must write the major and minor product for both of them if you're going to use a bromine aqueous solution. And then if you use co-alkaline dilute potassium manganate, so you form a diol. And if you use hot concentrated acidified potassium manganate, you form a carboxylic acid as the side products in here. Okay, so these are the answers of how you are going to write the equations in here. So always remember for chemical tests, reagent 1 mark, observation 1 mark, equation 1 mark, 3 marks in here. Okay, so that is how you are going to answer for 3A. Immediately we go to 3B. Two organic compounds X and Y are formed, but when put two in react with hydrogen chloride, why show an optical active compound? Actually, it's put one in. Sorry, I'm so sorry for the last minute changes. I'm so sorry for the last minute changes, but it's actually put one in. And I'm going to show you on how are you going to answer such questions in here. Okay, put one in, react with hydrogen chloride. Y is an optical active compound. So while if Y is an optical active compound, then Z is not optical active. So they only describe one, but they won't tell you the other. So you have to automatically know by yourself that if Y is optical active, then Z is not. Okay, so show how Y and Z are formed and determine their structural formula. 7 marks in here. When the question says show how Y and Z are formed, they are actually asking you about mechanism. Okay, mechanism. Okay, so if I were students to answer, our students to answer, when the question say put one in, so you must quickly write out the general formula. When you have CH3, CH2, CH double bond, CH3, CH2, react with the hydrogen chloride. So what you must know, what is the expected product first. Okay, so the expected product, you have two products in here. So first is CH3, CH2, CHCl. Then you have a CH3, 2-chlorobutane. And then the other expected product is CH3, CH2, CH2, CHCl. So in here, you can clearly identify which one is Y, which one is Z, because clearly this is an optically active compound because it contains a chiral carbon atom. Therefore, this is your Y and this is your Z here. Okay, so this will usually what I recommend students to do, because if you can't even write out this overall equation, then I believe that you will never be able to propose the right mechanism to answer this. So because it's a very big mark, 7 marks essay question, so you need to be very careful on the way of how you're going to write these essay questions. Okay. So we are going to continue with the next one, where what are the type of reaction? So you must also mention the type of reactions. So the type of reaction is a type of additional reaction. Sorry, electrophilic additional. Electrophilic additional reaction. So write out. Okay. Now, only then you are to propose on how does the mechanism take place in here. So the first step starts from, okay, you shall have the alkene CH3, CH2, CH double bond, CH2. Okay. Now, this is a very habitual way of how I propose the mechanism. Usually, I will show their arrangement in the correct shape, because this is a trigonal planar, so I show them in shape. Okay, so now plus HCl. Okay, and you must know that HCl in here, hydrogen is partial positive, chlorine is partial negative. Now, because this is a type of the electron attack, where the pi electron in here will first attack the partial positive. Okay, always remember the mechanism in here, because when you say pi electron, it involves a pair of electron attack. When it involves a pair of electron, you must use full arrow to represent your how does the mechanism take place in here. So always remember the trait of 21st century. It is the negative that attack the positive. Okay, it is negative that attack positive. Okay, so you must start off from the pi electron, which is the negative. Okay, it will attack the positive. You draw the arrow in here. You form bond like this. Okay, then since now if you draw the pair of electron attacking the hydrogen, now hydrogen has 2 bonds already. So which one will be broken? Of course, the one which has a longer bond length, which is the H and Cl. So H and Cl will undergo what we so call as a heterolytic fission. Heterolytic fission. So when this takes place, where carbon takes the positive, it will form what we so call as a carbocation. And when you form a carbocation, okay, You cannot have a carbon sharing the hydrogen, cannot, because hydrogen can only have one covalent bond, because hydrogen is only have one shell, 2 electrons, so you cannot draw sharing electron. Huh? So later, what does it mean by sharing electron? I'll show you when we discuss about the electrophilic addition reaction in the halogen later. Okay, so now when this C double bond C attack the hydrogen, there shall be 2 possible structure in here. So the 2 possible structure in here are CH3, CH2, CH. Now, if you draw the pi electron attacking the hydrogen, this is share in, the pi electron is shared in between the 2 carbon, isn't it? So you are attacking H, which is bearing partial positive, then it will become H plus eventually. So you imagine one of the carbon take the H, another carbon will take the plus. So if you draw this one take the H, then this one will take the plus. So this will form what we so called as a primary carbocation. Now, is this the only way that you can form? No, there is a second alternative way where you have CH3, CH2, CH, CH. Just now in the first structure, we can see that the first carbon takes the plus, second carbon takes the H, isn't it? Then you should have now, second carbon takes the plus, first carbon takes the H. So this will form what we so called as a secondary carbocation. Okay. So we, according to Markov-Nikov rule, we said that a secondary carbocation is more stable. But in the STPM, if you want to write more stable, less stable also can, but usually it won't bring you any marks in here. Huh? This is just for your knowledge to apply the Markov-Nikov rule. Okay. Okay. So now, then you have another side product in here. Our side product in here is actually a chlorine molecule. Okay, plus Cl minus. This Cl minus is from the heterolytic fission just now. Okay, and if possible, try your best to write like this is a slow step. Okay, then now you have a chlorine molecule, okay, which will have a negative charge ion. Okay, so I have a habitual to draw all the lone pair electrons in here whenever I'm proposing mechanism. So the lone pair electron of the chlorine will then attack the secondary carbocation. This lone pair electron will attack the primary carbocation so that you form the respective product of Y and Z. So this is the first step. Huh? Okay. So your product in here is CH3, CH2, C, H, H, and then C, H, H, Cl. Okay, whereas this one, you have CH3, CH2, C, H, Cl, and CH. Okay, so if possible, you mark this carbon as a chiral carbon atom once more. Okay, so this is your Y and this is your Z. Sorry, this is your Y and this is your Z. Okay, so that is how you are going to propose the mechanism for the these electrophilic additions of the hydrogen halide to the alkenes in here. So hope that through this question, I'll be able to show you on how to write the correct mechanism for the reaction. So if for more information, you can always refer to my books for the mechanism on how you propose it. Okay. Okay, so with that, that is for essay question number 3. Last but not least, we are going to go to essay question number 4. Okay, we are going to essay question number 4. Sorry. Okay, so essay question number 4 sounds like this. Chlorine is often added to petrochemical to produce variety of useful products as it can act either as an electrophile or free radical. Number 1, what is meant by free radical? So, what is meant by electrophile? So, electrophile, the main keyword to define an electrophile is only one, lone pair electron acceptor. Okay, lone pair electron acceptor. Okay. Electrophile are lone pair electron acceptor. This is the main keyword for electrophile. And then nucleophile, lone pair electron donor. Lone pair electron donor. Okay. So that is how you are going to define an electrophile. Okay? That is the main key. Just so teacher, if I just write lone pair electron acceptor, then okay or not? Okay, no problem. Okay, it doesn't matter because 1 mark only. You don't have to define very long. Okay, okay. So that is for number 1. And then number 2, describe the mechanism involved when chlorine react with ethene. Now, just now in the previous example, we have already witnessed on how the alkene react with hydrogen chloride, isn't it? Now is ethene react with chlorine. I'm going to show you on how the reaction. Okay, as usual, whenever you are trying to describe the mechanism, first of all, you must be able to understand what are the products that is formed. So if I were a student, definitely I will first write what are the equations that take place in here. So the take place in here, the reaction that take place in the chlorine is CH2 plus chlorine molecule in CCl4. Just even though the question does not mention, just write. You don't care where are the marks located. Okay. CH2, Cl. So just write this equation first. Only then you'll be able to you'll be able to propose what you want. Okay. So the reaction, the type of the reaction, always remember to put the type of reaction in the mechanism. So the type of reaction in here will be electrophilic addition reaction. Electrophilic addition reaction. So only then you try your best to propose the mechanism between the ethene and also chlorine. So we start from the first step where the C double bond C of the ethene will first react with chlorine, because chlorine is a non-polar molecule. Non-polar molecule. So the non-polar molecule will form what we so-called as an induced dipole. So it will attack the induced dipole of the H and Cl in here. Okay, then they will form this intermediate. This intermediate is what we call as a chloronium ion. If you can remember, you write the name. If bromine, we call bromonium. Okay, if chlorine, we call chloronium. Okay, so now this is the share in between the carbon-carbon. Now, teacher, why is it that in this case chlorine can share the bonding in here, while just now the hydrogen you cannot share? The reason is very simple, because chlorine has empty d orbital. Don't forget, chlorine is from third shell. So when you are from third shell, you have empty d orbital, so you can have more than 8 electrons. Okay. Okay. Then now once you see in here, have heterolytic fission take place, and you form Cl minus. So this is actually a slow step, right out a slow step. In here, and then the slow step in here, you form chloride ion. Then followed by the chloride ion attacking the carbon, and in here when this happens, okay, so the CCl bond in here will undergo heterolytic fission again, so that you form your desired product of 1,2-dichloroethane. Okay, and the way of how you draw the 1,2-dichloroethane, it must be in a Wick form, Wick isomer. What does it mean by Wick isomer? One must be above, one must be below. So is it, teacher, is it wrong that if I draw both Cl at the same side, like the one that you see in here? Teacher, can I draw like this or not? I do not recommend. I do not recommend that you draw both Cl at the same side, especially on mechanism. Mechanism, because mechanism talks in details on how does a molecule is formed in here. So try your best to write in the Wick manner of the molecule within Cl. So why you can't have both Cl at the same plane? So why cannot have both Cl at the same plane? Cannot, because of the steric hindrance, the steric effect. Okay, the steric effect will make this molecule to become unstable. So that is why the chlorine here must be in a big manner. Okay. Okay, so with that, that is how you are going to answer for question number 4A2. Okay. Okay, then we go to the next one, which is 4B. Now, 4B is also another challenging question. So, compound A, C5H9Br, reacts with ethanolic potassium hydroxide, okay, under suitable condition to yield compound B, C5H8. So, if possible, you write in your essay question like this, propose a flow scheme to understand what is all or what is going on in here, okay, which is A. react with ethanolic KOH under reflux to form a formula C5H8, which is B. So when B is added to alkaline potassium manganate, MnO4 minus in alkaline, co-dilute. So you form compound C with the formula C5H10O2. And then you further heat of the C followed by acidification. Okay, then you form a C5H8O4, which is D. Okay, and this D can react with sodium carbonate, okay, which give off a colorless gas CO2 in here. Okay, so determine the structural formula of A, B, C, D, each of them 1 mark, and write the equation. So in here, how many equations that you can see in here very clearly? How many equations that you can see? How many reactions that you can see in here? From A to B, 1. Then from B to C, 2. Then from C to D, 3. Sorry, too long. And then D react with the sodium carbonate. See? So 4 equations. So A, B, C, D, each 1 mark. 4 equations, 1 mark. So altogether 8 marks in here. Okay? So very straightforward questions. So your idea, your key in here is how do you deduce what is A, what is B, what is C, what is D? Now this is a very difficult question that if you cannot understand, then 8 marks gone just like that. But if you can understand, then all 8 marks are yours. So how are you going to deduce A, B, C, D? We start from the possible. You must know by yourself that haloalkane react with the haloalkane react under ethanolic potassium hydroxide. You must form alkene. Alkene react with KMnO4. You form a diol. When diol broken, you form a carboxylic acid. Okay. Now the key in here lies to here. Suddenly from O2 become O4. Okay, to understand this, okay, let's from my angle, from my angle of understanding, I'll definitely goes for this one, alkene first. So this alkene is C5H8. You have to think, C5H8. What are the possible molecules with the formula C5H8? Okay, so C5H8, because normal alkene will be, if C5 definitely with H10. But now here is C5H8. So therefore, this alkene is not a straight chain alkene. Instead of a straight chain alkene, you must know by yourself that this C5H8 is definitely a cyclopentene, nothing else already. Okay? Once you deduce one of the B, then A and C and D, you can naturally know by yourself that what is the possible answer. So then, if like that, how do you form this alkene? Definitely is from a bromocyclopentane. And then this alkene, when you react with a diol, then you form 2OH. And then when you acidify it, okay, because now you form diol and you further oxidize it, so it will definitely form a dicarboxylic acid, COH. See that or not? So there you go, very clearly, how do you form the carboxylic acid? If you want to double check, you check with the structure whether it hits your formula or not. So this one you have to know by yourself that okay, so you must know by yourself that this is a CH2. This is also CH2. This is CH. Okay, this is CH2. This is CH2. Okay, so C5H9Br. Then this is CH2. CH2. This is CH. This is CH. And then this is CH2. Therefore, C5H8. Then you have a CH2. CH2. CH. CH. CH2, therefore C5H10O2. Then here you have a CH2, 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 And if you count properly, C5H8O4. Okay, so very clearly that this is how the ABCD looks like here. Okay, then there you have all ABCD in here. And what are the 4 equations in here? You can write accordingly. Yeah? So try your best to write the equation as fully as you can. And the last equation in here, it must be balanced. Huh? So because in here you have a dioic acid, oh sorry, it's not 2 anyway, it's only 1. It's only 1. It's only 1. Okay, so when you have this, then it's not 2, so okay, so when you have this balance equation, then you'll be able to write. Okay. Okay, so I guess that is all for the essay question that I want to discuss with you in part 2, and therefore I shall end my sharing session for today. So if you like my video, please give a like, and if you want to ask any question, you can ask in the comment section. So to those who don't have the questions, you can go and purchase my modules from from Shoppee. Okay, you can purchase that. Actually, not much left. I only have like around 100 plus modules left. And once finished, I won't print out anymore because it's already almost the end of the studies already. So you have to wait for a new version if you want. And therefore, we end our lesson today. Okay. So I'll see you next time. So thank you very much.